Today we are going to see about sorting algorithm. Sorting algorithms are a set of instructions that take an array or list as an input and arrange the items into a particular order. Since they can often reduce the complexity of a problem, sorting algorithms are very important in computer science. Some of the common sorting algorithms are insertion sort, selection sort, merge sort, quick sort, bubble sort, and heap sort, which will be discussed in the coming sessions. Now let's discuss about insertion sort. Insertion sort is a simple sorting algorithm that works similar to the way you sort playing cards in your hands. The array is virtually split into a sorted and an unsorted part. Values from unsorted part are picked and placed at the correct position in the sorted part. An example. Consider an array with elements 12, 11, 13, 5 and 6. Initially, the first two elements of the given array is compared. Here 12 is greater than 11. So we must swap the position of 12 and 11. Now move to the next two elements. 13 is greater than 12. It's already sorted. So move to the next elements. Here both 5 and 13 are not in sorted order. So its position is swapped. Similarly, 5 is compared with all the elements in the sorted subarray. Finally, we get the array 5, 11, 12, 13 and 6. Similarly, compare 6 with all other elements and finally we get the sorted array 5, 6, 11, 12 and 13. Hope you all have a clear and better idea about insertion sort. Thank you.
Guys, now we are going to see about selection sort. Selection sort is used when a small array is to be sorted. Here, swapping caste does not matter. It is compulsory to check all elements. In the selection sort, the smallest value among the unsorted elements of the array is selected in every pass and inserted. It is also known as in-place comparison sorting algorithm. Let's see the working process of selection sort. In this algorithm, the array is divided into two parts. First is sorted part and another is the unsorted path. Initially, the sorted path of the array is empty and the unsorted path is the given array. Sorted path is placed at the left while the unsorted path is placed at the right. We will see by an example. Here the array elements are 13, 35, 25, 5, 32, 15, 40. First we should select the first smallest element in the array and replace it with the first position. Here 5 is the smallest element in the array and we are going to replace it with 13. So the sorted array becomes 5 and the rest of the elements are going to become an unsorted array, and we are checking the next element with the unsorted array. Here 13 is the next smallest element and we are replacing the 13 with the 35. Next, in the unsorted array, we are going to check the next smallest element. 15 is the next smallest element and it is replaced with the 25. Then 35 is replaced with the 25 and finally the sorted array arrived. Finally, the sorted array elements are 5, 13, 15, 25, 32, 35, 40 and we see the time complexity for selection sort. Best case time complexity for selection sort is omega of n square. Average case time complexity for selection sort is theta of n square. Worst case time complexity for selection sort is big O of n square. The space complexity for selection sort is big O of 1. Hope everyone could understand the selection sort clearly. Thank you.
Today we are going to see about merge sort. It is a sorting technique based on divide and conquer technique. Merge sort is one of the most popular sorting algorithm that is based on the principle of divide and conquer algorithm. Here a problem is divided into multiple subproblems and each subproblem is divided individually. Finally, these subproblems are combined to form the final solution. So we first divide the arrays into equal halves and then combines in a sorted manner. The time complexity needed for merge sort is big O of n log n and it is applicable for all cases like best case, worst case and average case. Let us see an example of merge sort. Consider an array of size 8 and we first divide these 8 elements into half, so we get 4. Then we recursively divided these elements into n by n, that equals 1. Then we goes into a merge, that is called conquer. Then we recursively conquer these elements to form in the sorted manner. The main disadvantage faced by this merge sort is it requires extra space to complete the program. Thank you.
Hi guys, now we are going to see the topic quicksort. The conditions for quicksort are the I value should be lesser and j value should be greater than pivot value, or else we should swap the I and j values. And if the j value crosses the I value, we should swap the j and pivot value. Now we can go to the problems. Let us take these numbers as example. Always the first number should be our pivot value and the number next to the pivot is ith value, and the last number should be our jth value. As per the condition, 40 is lesser and 70 is greater than 60. So we increment our ith value. Now I value is 90. Now I is greater than pivot value. So the condition validates. Now we check for jth value. We decrement j. Now j value is 50. Both I and j value validates. So we swap I and j value. Now the value of I and j are 50 and 90. So now the condition satisfies. So we increment the I value. Now the ith value is 80. Again the condition validates for I. Now we decrement the jth value. Now the value of j is 30. Both I and j value validates. So we swap the I and j value. Now the value of I and j are 30 and 80. Now we increment the ith value. Now the I and j value are in the same place as 80. Now for the I value, the condition validates. Now we decrement the jth value. Now both the I and j values crosses each other. So we swap the j and pivot values. Now the pivot value as 30 and jth value as 60. Now we split up into two parts having j as center. The value of 60 won't change up to the last. In the left side, the first element 30 as pivot value, next to 30 40 as ith value, and last element 50 as jth value. In the right side, 80 as pivot value, 90 as ith value, and 70 as jth value. First we will see the left side. In this, 40 is greater than 30, so the condition validates, and we checking the jth value. J is greater than pivot value. As the condition satisfies, we decrement j value. Now the jth value is 20 and both the I and j value validates. So we swap I and jth value. Now we increment the ith value. As the condition validates, we decrement the jth value. Now both the I and j value crosses each other. So we swap the j and pivot value. Similarly, we do this in the right side and we get the sorted array as 20, 30, 40, 50, 60, 70, 80 and 90. Hope everyone could get a clear idea about quicksort. Thank you.